Okay, so we're recording now. So you're all very welcome. Oh, hold on, let me just go because I'm on both. Let me just pull this forward in terms of. Okay, so you're all very welcome to the latest in this series of workshops. I had no idea at the start of the year when I started doing these that I would still be doing it in October, and we have a talk next month, which I'll talk about in a second, and then we will probably have the final workshop of this series next month, which is just going to be a wrap up, and I'm going to talk about like presentation and stuff like that. But you're all very welcome to Dublin Data Science and the meetup, the workshops. We try to have something every month. This, like I said, we have the workshops. We've had a good few speakers this year, which I've been delighted because under COVID, getting speakers has been a bit of a challenge because, as I always only half jokingly say, our main method of recruiting speakers is arresting people at the bar after our talks and saying, hey, would you give us a talk about that thing I just heard you talk about? And obviously, with lockdowns and everyone kind of working from home and all that, and still, even personally, still a little bit squeamish about meeting up in person, although we are hoping to do some kind of, depending on how things go now, there was a plan to do maybe a Christmas drinks thing. Now that was all in advance of the COVID numbers spiking with the Delta variant. So, I mean, we'll see how those survive contact with the enemy. But we will be back next month with a talk as opposed to a workshop. So it's a former speaker in the past, a woman called Lucia Cabrera. She has done some work on politeness measures, in particular, and like gender differences, and in particular used film scripts in romantic comedies and analysed essentially the gender differences in politeness, which I thought was quite fascinating. So she's going to give us a talk on that, and basically the work she did in terms of analysing the data and how she parsed all the film scripts and stuff. There's a bunch of interesting things for her to talk about there. So stay tuned for that. The placeholder went up on the website on Meetup either yesterday or today. More information will be put on it in terms of the blurb and whatever, probably tomorrow. But yeah, that'll be kind of mid-November. I think it's the 17th or something. We have that scheduled. And then to round out the year, the final workshop of this series will be done in December. And then we have a couple of speakers. I kind of have a couple of people hopefully lined up for the start of next year, for 2022. More details on that to come. But okay, for the purposes of this meetup, we'll get started. So for those of you who are relatively new to this game, I try to make this as interactive as possible. By all means, if you have any questions or whatever, ping them in the chat or just unmute and ask the questions, whichever is which. I kind of have two screens here, so sometimes you'll kind of see my eyes kind of move up that way. So I kind of have the chat and the participant list up here on this second screen. So I am going to try and keep an eye on both. So if you have any questions about what I've done or what's happened, by all means, keep them here. Roughly the way we go is we've kind of penciled in 2 hours for this. The rough structure is I'll go for the next 40 to 50 minutes, depending on how we get on. I usually take a 5 to 10 minute break in the middle, just to let people run, grab a cup of tea, go to the bathroom, whatever they need to do, quick break. And then we'll come back around the hour, and it'll be 8 o'clock plus or minus 10 minutes, depending on where we get to. If there's a good natural break, I'll finish early. If not, we can run a bit late and take the break later. But I do try and take a break anyway, and then we'll come back and I'll go on until maybe 8:45, 10 to 9, depending on how questions are. At that point around there, we'll wrap up in terms of the workshop. I usually hit stop at that point, and if anyone wants to stay on to ask questions or whatever, by all means, just hang on. I'll be around. I usually kind of book myself out until 9:30 because sometimes a couple of people just stay on just to chat or whatever. But okay, all right. So let's get started because there's quite a bit to cover tonight. Actually, it's more than I expected to do. So what I'm going to do for the first 5 to 10 minutes is repeat myself like I have pretty much in every workshop, because I am conscious that while I recognize a bunch of names here, I can't be confident that everyone here has been at all of the previous ones or even any of them. So I'm going to give a quick summary of the project as a whole and the point at which we've gotten to, and then I'll kind of dive into the meat of the tonight's talk, which is all around basically taking what we have done so far and figuring the meat of the content that we're going to give as the final delivery of the project is kind of the way I'm thinking about it. I don't have a good or elegant phraseology for that, but that's basically where I'm thinking. It'll be a combination of visualization, probably some modeling, some plots, and figuring out exactly how to do things. And then in the final workshop, I'm going to talk specifically about like project delivery, like how do we actually present our visualizations? What do we think about doing? How do we kind of craft our messaging, all that kind of stuff. So, okay, before we start, does anyone have any questions? By all means, pop them into the chat or just unmute yourself, whichever you want to go. I'll just give you a quick second here. If anyone has anything at all that they'd like me to go over, please put them in the thing, but I'll briefly mention what happened. So the idea of this project is to show essentially soup to nuts is an old joke, an old phrase, I mean, from I think about the early 20th century, that you started your meal with the soup and you finished with the nuts after the sweet. So the soup to nuts basically means from start to finish, like alpha to omega. So my whole idea was I'd never actually seen anyone talk about doing a full data science project from start to finish. And I thought that to me seems like a good topic for a workshop and for a workshop series. My original idea, laughably naive, was to have it in 3 or 4 workshops, ideally 3. It became very, very apparent very quickly on from me just in my head to say, no, that's not going to be enough to do it properly justice. And I wanted to so it's kind of expanded to take, I think this is session 7. So in total, it's going to take eight in total, although I think the final one will be much lighter. And just show like the ins and outs and the ups and the downs and the problems you encounter and all the things that are incredibly important in real life, but tend to get brushed over a lot when you read your blog articles or you see your presentation or all the other things that people talk about. And the other really thing I wanted to hammer home is the value you deliver in a project is often comes from very unsophisticated things, in the sense of just like taking your data and transforming it in a sensible way and then plot and showing the results and visualizing the results of that can be extremely valuable to someone, much more so than fitting predictive models that may or may not work and have questions over how valid they're going to be in the new one. We're actually going to see that shortly. So there's all that kind of, so I kind of wanted to emphasize that as well. Now, and that's been kind of evidenced because even in the modeling ones we've done a couple of models where we talked about some various things that we looked at. One, I kind of took a time out to go down, a blind alley, the very last workshop we did, which was all on buy till you die models. I kind of went ahead with it, even though I realized at, very early on, once I started modeling, that, which was the reason why I started this project, I realized pretty quickly that it was just too complicated and it's too hard to explain. And it's not necessary. There's simpler ways to get the outcomes you want. So I kind of have also kind of shown the blind alleys that you go down. And, we can talk a little bit that now it's not a complete loss because the work that went into the BTYD models are actually going to form the basis of the workshop I'm going to do in 2022, which is going to be basically a revised Bayesian data analysis workshop. But rather than deal with, tossing coins and simple distributions, I'm actually going to do a proper buy till you die model and kind of introduce the Bayesian logic that way. But anyway, that's a topic for another day. So so basically the data set we looked at, you can see it here. It's a very, very simple data set. It comes from an online web store dating from, you can see, from about 2009 to from very late 2009 to basically the end of 2011. And it's not exactly clear. The data set I got from the UCI machine learning repository, it's called Online Retail 2. As you can see, there's about 1,000 rows in it. I made a mistake initially because it comes in an Excel file and I only looked at the first tab and didn't pay any attention to what I was looking at. And as a result, only had half the data the first time I did it. Sorry, Alex, I'm just going to mute you if you don't mind. Just there's a bit of background noise actually, and Rivera as well. Oh, you've muted. Perfect. the classic thing is I didn't follow my own advice. What I should have done is, now I normally don't have Excel involved, but you can get like LibreOffice. There's a few ways to get access to Excel. It's always worth opening, if you have the means to do so, always try to open the data file in its native format if possible, purely to catch yourself from making those stupid mistakes that I made. I was actually a good few hours into the project. I think I was getting ready for the very first workshop when, and by ready I mean that day, when I noticed suddenly, hang on, there's supposed to be 1 million rows on this, and it only occurred to me then I should open this in Excel, and I noticed there was the 2 tabs, and I just made that mistake. So that, and that's, I've kind of created this synthetic variable here called Excel sheet, which just tells you the sheet that it came from, and I've combined the data. So you can see there's not actually that much data in it. It's got an invoice ID, a stock code, which is the code number for whatever piece of stock that was part of the transaction. It's a description, which is a free form piece of text related to the stock code. There's the amount of the quantity of that item and the invoice date, the price that item was sold at, and the customer ID of the purchase, and the country of the customer ID. And that's it. That's all the data you get. And there are relatively limited information even on the online retail. And I've had a look at the papers, and while it gives you some information, I certainly didn't find all the data that I was looking for. So there's a bunch of stuff that we had to make up. Basically, we had to kind of invent a bunch of things and answer the questions ourselves. Now, and this kind of flies in the face of one of the points I was trying to make for projects like this, which was very simply, the domain knowledge is really important, but also stakeholder input. So ideally, if you're working on a data set, you should always try to work with someone who understands where that data comes from. Just one second, I'm just going to close this door. There's a door here, I'm conscious. Now, okay. And, we don't have any of that information. So there's a whole lot of questions that came up from our data exploration almost immediately. And we went through all this. There's all sorts of visualizations in terms of missing data and having a look at what's there. There's all these things. But, it also became quite apparent that this wasn't so much the data, the sales transactions. It was weird. So there was a bunch of extra things in here, including like admin costs and shipping costs. And there was a bunch of things in here that you wouldn't expect to see if it was purely a sales transaction data set. There was like bank refunds. Exactly. Yes. Sorry, Patrick. He said I saw there's academic stuff. So there's 2 online retail data sets. There was one from a Chinese bank, I think, or some kind of Chinese retailer, I believe, was the first one. That's online retail, just online retail. And then this other one was a bit more recent than that, and it came on only a couple of years ago. And again, but I think they're, in terms of structure, they're broadly similar. Okay. Sorry, do you have a question, Kenneth? You just unmuted, so. No, okay, I'll just put you on mute. Oh, okay, all right. So I won't go into too much detail in the the exploration of all this. We've spent quite a few workshops either focusing on it specifically or kind of returning to it. But essentially what we would do is there was a whole lot of data cleaning that had to be done, and some of which actually did not become apparent until much later along, when I was because there was 1 million rows, and it wasn't easy to kind of find the weird ones, and it was only from later on when you would see some really anomalous bits and pieces. Also, the other thing I discovered from somewhere is that there was part of these transactions were also transactions involving wholesalers. So it seems to be an online shop for like a kind of an Etsy style bric-a-brac store. But even though it's an online website, it only seems to take transactions during working hours. Like it closes for 10 days over the Christmas and stuff. So it was just odd. There was some odd kind of anomalies in the data, which aren't necessarily what you expect. Like if it was a fully online retail store, you would expect transactions to happen all the time. But it seems possible that maybe while it was an online store, all they did was took the orders, and then the orders had to be entered manually into the system, or some kind of, it was a bit odd. So anyway, so we had to deal with all that. And then there was returns in there as well. But the one big problem with the returns was the returns were kind of denoted as an invoice number with a negative on the quantity, and they didn't link it specifically to the previous sale. So there was a bunch of kind of, I did some work on trying to match them up, but eventually I kind of said, if it comes up later, I'm going to spend more time in it. But for now, I'm just going to ignore it. Also, there was a bunch of transactions that didn't have, I think it was they didn't have a customer ID, and I believe they were some kind of wholesale bulk, because also there was some weird analysis based around that as well. So there was a bunch of things we kind of had to just throw out and, you know, boil things down into a data set that we could actually start to work with. So that was kind of what we spent quite a bit of time. Then once we had the data, we started looking at potential modeling we could do with it. So we had a bunch of different ideas. Initially, one of the reasons why I actually chose this data set was because I'd heard about these BTYD models, buy till you die, and that sounded like a very interesting modeling approach. And it was something I wanted to try out, and I therefore worked on this because it was very natural. Now, as I said, as it turned out, the buy till you die models, while really, really cool and really, really powerful, they were just too complex for this, and I had problems fitting them and all sorts of things that I discussed in the last workshop. So instead, I kind of took my step back. But we also looked at things like association rules, which is a basket analysis. So you're essentially saying, okay, well, if a customer buys this item, how does that affect the likelihood of this other item being in the same basket? So a good example of it is, you know, there's a certain probability a customer will buy butter, let's say from a grocery store. But if they buy butter, how does that affect the chances of them also buying bread? And the idea is that you use these kind of association rules to create your like Tesco club card style ideas, where of, oh, you seem to buy these items, customers also liked these items, and that sort of thing. Association rules were quite good, and we are going to talk about them in this. The one downside they have was, certainly in a website like this where you don't have very rich product data, they can be useful to create these associations, but you also end up with very obvious kind of things together. So like if you're buying baubles, like say Christmas lights, if you're going to get Christmas lights in green, you're also highly likely to buy Christmas lights in yellow. You know, that some of the association rules didn't really pan out, or at least I didn't find them as useful as they were. But having said that, I think they'd be a very useful tool to create for stakeholders, and there's some nice inbuilt shiny apps that we'll probably be talking about in the next workshop that we can talk about in terms of, you know, project delivery. So we looked at association rules, we looked at buy till you die. We also looked at a thing called RFM modeling, which is kind of tied in with buy till you die, which is recency frequency monetary. I'm going to go over most of these techniques in this talk. We'll talk about that again. So we basically, once we had spent the first couple of workshops, you know, working on the data, doing the visualizations, figuring out where we're going to go, what we're going to do, you know, what's set up here. And that, you know, some of the ideas came as a very natural consequence of the analysis we did, of the exploratory analysis. We then basically spent a couple of workshops just trying things. So we tried out some association rule stuff, created some graphs, created some tools, like had a look at the different associations. How do these help us out? We tried that. And like I said, we tried some buy till you die models, too complicated. So we essentially put a pin in that. But as a result of looking for the buy till you die models, I also came across these recency frequency monetary ones, which I found really useful. And those are basically that, and the association rules, and some simple graph analysis. Because the other thing you can do with a transaction data set is it lends itself very naturally to a graph. Because what you can do is, if you create each transaction becomes a node, and if each item becomes a node, and then, you know, if a transaction appears with goods in it, you create a connection between them. You create this big graph of all the connections, and then you can do graph clusters. And then from the cluster analysis, you get rid of all the transactions and just look at the items that are remaining. Suddenly you've got like items that are clustered together in terms of transactions. So that's the other thing we looked at, and we'll talk about that a bit more in this workshop. We could also use association rules. So association rules also, there's a way of converting those into graphs, and that's something we've also done. But we did a bunch of things, and now in this workshop, having kind of spent the last couple of, and this is typically what happens in a project. Like, it's very, very rare that you're when you're working on a project that the people who ultimately want the work done will have a very specific ask. Now, they might have very general asks like, we want to know who our valuable customers are, or we want to know what's selling well and why, or we want to know if we can, some recommendations for a loyalty program. You'll have these kind of very high level ideas. Sometimes they won't even have that. Sometimes the remit will be, we've heard you can do magic with data. Could we have some of that magic, please? And it will be very, I know, and then you have to kind of start to talk to them and kind of tease out, well, what exactly do you mean? A, what do you mean by magic? And B, can you be a bit more specific? And even if they are being specific, like, well, what do you mean by good customers? I mean, how do you mean customers who purchase a lot? Do you mean who spend a lot, or don't return their items, or like what exactly, does that mean? And how, and that's where I said before the domain knowledge comes in. I did actually hear, incidentally, and this is a flaw in the current analysis as we've done, because we kind of had to make some calls and some judgment calls in the absence of, external stakeholders. I didn't really analyze returns at all, and I don't. In all the things we've looked at, I've kind of excluded them from all this analysis, which may or may not be important. My gut feeling is it's a flaw in this work, and this is something that almost certainly, if we were to continue on this work, I would look to rectify it. However, we're also hampered by the fact that we can't directly relate returns to specific transactions, because it doesn't have like a related transaction key or anything like that. That's just not in the data. So you end up kind of having to create kind of, okay, well, what's the last one that was traded at this price for this item? And of course, returns could go across multiple transactions. Once you open that, it becomes very much a Pandora's box, which is why I just left it and just ignored it. However, certainly in retail, from what I've heard, if you're doing online retail, I have heard anecdotal evidence that ignore returns at your peril, because typically the way the standard works now is whatever about initial shipping, returns are often eaten by the retail shop. And that's kind of a standard Amazon has set, certainly, and some others. And that can really hammer your bottom line, because the cost of the returns, not only are you losing the sale, you're essentially paying for the shipping twice as well. So, it all kind of adds up. So, judging your customers and completely ignoring the returns could give you a skewed view of the world as well. And that's something you definitely need to pay attention to. But with all that in mind, that's kind of, so where we're going to go today is we're going to try and put the various models we've built in the past. So the association rules, graph, building the graph, looking at some the RFM models, which I'll explain quickly as well, putting them together. And essentially what we're going to try and come up is essentially some different customer cohorts, and then some different like clusters of products, and then essentially try to see what kinds of products do our good customers buy. Just as that's the best I could think of in terms of, without going completely down a rabbit hole. And we're going to talk about like one of the ways in which I came about this. Now, the other thing I should say is, for a relatively simple data set, I've been actually very pleasantly surprised about A, how interesting it is, but B, the potential for analysis here. There's quite a lot of very interesting things you can do with this simple data set. Even like I said, we could actually do quite a deep dive on the returns and try and analyze that kind of thing, which I haven't done. So there is actually quite a lot of scope for further work here. And we'll talk about that as well, because that can be useful as well when you're handing over or when you're presenting the results of your model. It can be very useful to also have answers to the questions of, if it's very well received and more work is to be done, being able to say, well, here's some extra things we'd like to do, But before we begin, before I kind of start the kind of talking about putting the models together, does anyone have any questions? I want to take a quick cup of tea. No. Okay. Very good. I'm going to take that I've got one no and a deafening silence from everyone else, so I'll assume everyone's okay. All right. So, like I said, we've done some analysis. There's a couple of interesting things. Like, let me just before we start. We did some analysis on the stock code lookups, some buy till you die visualizations, like just plotting transaction dates, looking at like these are where customers. So each of these is a customer ID. Here's when they first had the transactions, and then each dot represents a transaction date. So when the customer made a date. Now we aggregated everything down to the day. So if there was multiple transactions on the same day, we could have analyzed them all separately, but to me, it made a bit more sense just for the purposes of simplicity. And also, if they're buying something on the same day, I kind of made the logic that they're essentially the one transaction. Now, we could have been more sophisticated and collapsed everything within, say, a 12-hour window and gotten very fancy. But again, you know, I want to keep things relatively simple because the perfect is the enemy of the good with a lot of this stuff. And just compressing down to a single day, even that, to be honest, is probably more resolution than we really need for the purposes of what we're talking about here. So yeah, so we looked at some dropout rates. There was a bunch of different things we did, you know, looking at the cohorts. There's all sorts of interesting stuff in there, but you know, we've gone over that before. All these videos are on YouTube, and you know, they're available for kind of looking there. So we're going to start building some models, some kind of taking what we've done before and build some models. So like we said, I kind of had analysis before. You know, the invoice ID, the stock code, the customer ID. I'm using this in R, but you could equally do all it. You could do most of what I've done for the purposes of this model. I think most of it will be available in Python. Other programming languages I'm not sure about. The only thing I wouldn't be sure of in Python is association rules, but I can't see why they wouldn't be, because from what I remember, association rules are pretty easy done. So I wouldn't be surprised at all if there was stuff in Python for all of this. But I use R because that's generally what I work in. And you know, it works fine for me. We created some extra stuff as well, like, you know, the exact date time of the invoice. Invoice date was the day, whereas the invoice date timestamp has the actual time of the day. And then we included, like, you know, day of the month and what minute, and you know, breaking down a whole bunch of things around the timestamp of the invoice, because that could be interesting. And then I added a couple more things like, you know, the total stock value, which is basically the product of the quantity and the price. So, you know, adding some bits and pieces like that. We're going to analyze it down and, you know, compress it down into various pieces. We also extracted from the data set some cohort information. So kind of reading around all of this, for what people have said is it's important to treat your customers as cohorts of customers, usually cohorting on when they joined the website. So in a lot of, apparently it's you know, like everything else, there's no absolutes in this world, but it's quite common apparently in retail that when your customer joined your site can have quite a significant effect on their behavior. Now, how that works, I'm not exactly sure. I'm sure there's a myriad of reasons for that. But as a result, quite often you will break your customers up into different cohorts, and you'll either run the model separately or you'll treat them differently, depending on their cohort. So I took some very simple data, and basically by each customer, very simple things like what date did they first transaction and how many transactions have they made within the data set. And we also, in the past as well, I had essentially taken the product data, because the other downside with this data set is there was almost no product data given. It was literally a stock code and a free text description, and that was it. Now, we did actually, at the suggestion of someone in the chat, very much the start of the project, we checked to make sure that each stock code unique, because there's a possibility that, you know, old stock gets taken off the system and they reuse the stock codes later on. So I wanted to make sure, like, you know, if we look at the different stock codes and the free text that's in there, how similar are they? Now, in general, they were pretty similar. There were a few differences. We can talk about that later, but there didn't seem to be anything that was massively different. So it did look that we can roughly treat each stock code as a separate entity and not have to also worry about the date of that use of that stock code. Otherwise, we would have had to, like, append it somehow with some kind of a date to disambiguate the codes. So we didn't have to do anything like that, thankfully. But because we had very little information, like, ideally what you would like maybe is some kind of product hierarchy where you have some kind of categorization. So each product fits into a certain category, and you can kind of break it down that way. Now, maybe it would exist for this, but we certainly don't have access to it. So instead, I basically had a little lookup code which compressed all the text down from the code into this. And we will use this a little bit later because I use these words to actually create a word cloud later on, just as a way to kind of see if there was similarities in the various clusters that we did. Okay, so we've got a bit of data here. We've got, in addition to all the transactions, we also have some cohort data, and we have some very minimal product data. Now, it's like I said, it's a lot less rich than we would like it to be, but it's not too bad. Okay, so does anyone have, again, does anyone have any questions before I keep going? Just while I scroll down. Okay, so we're now going to, oh, hi, Raphael, how are you? Hope things are good. Good to see you again. I think I mentioned this the last time, by the way. I don't know if it's relevant to you, just as a quick aside, but the buy till you die models were originally used for brokerage stuff. So it might be, I mean, I don't know if it would be of interest to you, but it might be worth having a quick chat about that. I can point you, I might be able to point you in a couple of useful directions for you. But anyway, that's neither here nor there. Okay, and certainly we'll be doing that in a lot more detail in 2022. All right, so the association rules model was kind of the first thing we looked at when we got the data, and it's basically a basket analysis. What you're trying to get is, it's effectively a conditional probability calculation. So you have like a baseline probability of what is the likelihood of product A appearing in a basket, and that would literally just be the proportion of baskets for which that item appears, right? So let's say, for example, it's, again, to go the supermarket route, let's say 10% of customer, let's say 10%. I'd say it's, well, it's probably higher than that actually if it's a grocery store. But let's say 20% of purchases from a Tesco's have milk in them. As in, when someone goes to a checkout with a basket of stuff, 20% of them have milk, right? And that's just like across all the transactions, 20% of them contain milk. But if you know that someone has bread in the order, it means they're more likely to be buying staples as part of that order. So therefore, when there is bread in the basket, then maybe the probability of there being milk is now 60%. So the way that works is that's said to have a lift of 3 because it's 60% divided by 20%. So it's actually the conditional probability is 3 times higher, right? So that's kind of, as a very kind of highlight, there's these ideas of lift and support and all this kind of stuff. So that's roughly what you're trying to do. What you're trying to do is there's a bunch of algorithms to do that. You could brute force it, where you just calculate the conditional probability of everything by everything, but that's a really, really slow thing to do because basically it's an n squared scaling problem. So the more items you have and the more baskets you have, it basically scales like a pig. So they have these various algorithms that essentially mine out the most likely ones based on various, they have various kind of heuristics to kind of figure out what the valuable ones are. And you can kind of, in declining support and declining confidence and all this kind of stuff. So we talked about this a lot, but essentially what you're trying to do is find the products that co-occur. And what you get from the result of it is this kind of thing here. So you get a rule that like this product here, 22459, basically has an effect on 22458. No, no shock there, their ID are together. And basically what it means is that like it's got a lift of 134. So basically what that means is that if you've bought product 22459, then you're 135 times more likely to be buying product 22458. Okay. Now it would be great if they had more, more descriptive names, but that was the reason why I created that lookup table for creating that. And this just comes straight out. So I did a bunch of things. I looked at a bunch of stuff, and this is all kind of covered in earlier workshops, but I'm kind of putting it together here in one place so that we don't have to dig out. We basically just take these rules and we plot it on a graph, and we have, as you can see, there's 6,000 rules in the data set, and we get this kind of nice visualization that well, that's a bit messy, I admit. Is this interactive? I thought it was. Hold on. It should be. Or maybe it isn't. Maybe it's later on. So we end up with these graphs, and you can see there's product names there, and then there's association rules. Oh, this must be the one where it's, so yeah, so I basically took some of these plots. So you can see when we zoom in here, we have a whole load of rules in here. And essentially what this means is that, like, let's pick these rules. We get this nice graph. So rule 52 says that when product 22382 is purchased, rule 52 says it impacts 20726. And because we get a nice lookup, we can see the lift is 8.74. So essentially what we've done is we've taken a whole load of these rules, and you don't have to have individual products. You could have, you know, if you have, so let's say, for example, using our earlier analogy, we had, like, you know, 60% of the baskets with bread. But let's say, for example, 90% of the baskets that have bread and butter also have milk in them. Well, then that's another association rule where the presence of bread and milk, so bread and butter, have a lift. So that would be 90.9 over 0.2, which is whatever that is, 4.5. So there's all those kind of rules. And you can see here, we're very naturally getting a directed graph from these association rules, okay? And once we have the graph on it, there's a couple of things we can do with it. But what I started thinking about was, let's use this to cluster the graph. So we have a directed graph here. There's a couple of different ways we can deal with it, but rather than dealing with a directed graph, let's just make it an undirected graph for all the association rules we have, and then just create clusters from them. Or if there isn't exactly clusters, we could create, like, what are the disconnected components, because that might kind of segment our data set nicely. But one of the problems we had there, and we did that there, so we're creating, like, on the disjoint parts of the graph. So this is kind of, I'm not going to go through any of this, but essentially I wanted to then, you can basically pull out, you get these small clusters, and then you get a big blob in the middle. And what I wanted to do then was I would take all those various disjoint parts, they're all individual clusters. And then the big blob, I'm going to run like a community detection algorithm, which is, what would you communicate? I don't know, Patrick, is the short answer. We're going to talk about that a little bit in the next session. Sorry, I have a question here. Would you communicate to the business what you have there? It would depend. It would depend. There is a very nice little Shiny app that you can give. There's two ways to answer that question, is the short term. There's whether or not it will make them happy and whether or not it's useful. And they're not necessarily the same thing. So sometimes there is value to you personally, and it's very cynical, but sometimes it's good to give your stakeholders a toy to play with, especially if it looks good, even if it doesn't necessarily convey a whole load of value. They might actually enjoy and gain buy-in from the fact that you've given them something interactive where they can, you know, change some values and move some sliders around and see the effect on the, like, Shiny apps are really good for this. And even if it's not particularly useful, they might think it is, and therefore they'll also have gotten something from you. So I'll talk about this a little bit more next. The short answer is I probably will give them something. I'm just not sure exactly what yet, because it would also, you also don't want to make a rod for your own back. Yeah, exactly. So sometimes also there's the joke of called CEO porn. Sometimes you want to give the CEO something to play with, especially if it looks cool, and they can load it up on their phone and show it to their mates and talk about how cool they are. And that sounds really dismissive, but it isn't, because they're not technical people. And if you can show them something that looks like they're getting value for money, that actually buys you the time to actually do the really valuable stuff. So sometimes it's, and I have done this, I will not lie. Sometimes when you get data and you're working on a project, it's sometimes worth churning something out really quickly if you can, and delivering it to the powers that be so that they can look at it, exactly to make Raphael's point, in terms of just to establish trust. Because if you can give them something valuable, they know they're not, basically, because, you know, an awful lot of projects just end up turning into grey goo and you get nothing for it. Whereas at least if you can produce some relatively simple visualizations, even if they're not necessarily that valuable, or if they're not seen to be that valuable, Quite often they are, if it's a data visualize, like if it's some kind of exploratory visualization, that itself can be quite valuable. Now, like, I'm just showing these for the purposes of me. By the way, none of this is aimed at going outside the team working on this. Like, that's what I'm going to focus on for the final workshop. And it might not even necessarily be in terms of a presentation. It'll be more like creating a summary of what we've discovered, and then thinking about things that we can deliver. And like, this is very, very wonky, but there is in the A rules viz package, which was some of this is based on, there is a very nice shiny app that builds on top of it builds the association rules and gives you some tabs to play with and let you do stuff. And that might actually be worth like creating and delivering and then giving them something to play with, because then they'll start asking questions. And really what you're trying to do is get them to buy in and draw out from them things, because they'll come back to you then, actually, I've just noticed this, is it possible to do that, and all that kind of stuff. Okay, so it's not a simple answer to the question, and I'm conscious I've probably massively over answered it, but yeah, so we're doing some graph clusters, and there's a few different ways in which you can do community detection on the networks, and so I just tried a few different ones. Most of this is using a package called tidygraph, which is really, really good, but it also wraps another really good library called iGraph, which was written in C and is definitely available in both R and Python, although I know Python also has NetworkX, and there's probably a few other libraries that like are more commonly used now. But what I was trying to do here is, what I didn't want to do was use a clustering algorithm that basically just, created a bunch of very, very small clusters with 4 or 5 items in them. I wanted to try and cluster the data as much as as evenly as possible, not as evenly as possible, but create like meaningful clusters that have a bunch of different things in them. So what I'm trying to do here is, and there was a few different ideas. So there was a bunch of different clusters that came up here, and then I was looking at how many of them are there. So if you look at this cluster here, you can see basically the cluster size. This cluster 1 has over 80. So the group fast greedy isn't too bad. And then I kind of arbitrarily set a size of having at least 5 items in the cluster, because a whole lot of clusters that have just 1 or 2 items in them aren't particularly useful in terms of what you're trying to achieve here. So eventually, if you look, actually Louvain was not bad at all. So most of it created about 20 clusters with at least 5 items in them, and then a bit of a tail of the rest. And the spread of cluster sizes here, what I've done here is I've basically taken all the clusters that came off the community detection, and it's how many clusters were there at each of these sizes along the x-axis. So the x-axis is the amount of products in each cluster, and then the y-axis is the count. So ideally what you would want is a decent spread of sizes that don't have too much. So like I said, I went with Louvain here because there's a bunch of clusters of similar size, and then there is also a bunch of clusters of decent size, and they all added up. Now, one of the problems we have here with this, and I'll take a break shortly, is that the coverage of the association rules is very low. So it only included, I can't remember exactly, there's about 5,000 products that were transacted upon in the data set, I think, give or take. I'll check that during the break. But because of the way the association rules work, most of them, I think there was only about 1,000 left, which is why, like, if you add all these up, you can see that they probably don't add up to, they certainly don't add up to anything like 1,000. I think it comes to about, to 5,000. I think it comes to about 1,000. So we're losing 80% of the universe using association rule graphs. So instead what we did, and we can do that, I assigned them to groups, and that kind of became a clustering. But what you'll see is that most of the products don't get assigned to any cluster at all, because they're not in any of the association rules, because for whatever reason they were cut off, or there wasn't enough. So instead what I did was I created a graph clustering approach. So instead, a transaction based. So instead I took the full database, and rather than working on the association rules, I just took the full data set, And then I built a graph based on the nodes are both transactions and products. And then there's an edge between them if that product is in that basket, that transaction ID. So you get this big graph. It's a much bigger graph, so it's a lot more memory intensive and it's a lot more work to work on. And then I did some community detection based on those graphs. And that way, at least, when we do our community detection, all the products in the data set get covered, get assigned to at least one cluster. And that was the one that I ended up working on, because while the associations rules were very useful from down one angle of things, for the purposes of clustering all the data, I wanted to have much better coverage of all the items. Okay, so we'll talk about that after the break, because that's actually a good place to stop. So it's about 5 to 8 now. I hope I've kind of kept everyone with me. What we'll do here is we will take a break for about 10 minutes. So we'll come back at about 5 past 8. But I will hang around for a minute or two in case anyone has any questions. But failing that, by all means, we'll take a break here and we'll be back in about 10 minutes. Okay. So I'll hang on for a minute. If anyone has any questions, just pop it into the chat. Failing that, I'll turn off my video here and I'll wander off for a couple of minutes and then come back. I have found that having drinks nearby is good for the throat, because I end up talking for like 2 hours straight. Anyone got any questions? No. Okay. Well, what I'll do is I'm going to turn off my my personal video camera here, and I'll leave the screen share up. But what I will do is, if anyone has any questions in the next 5 or 10 minutes, feel free to pop it into the chat. And what I'll do is I'll address them as soon as I get back from. I'm just going to run off and re-up my cup of tea probably, or and just run to the bathroom. So yeah, if anyone has any questions, just pop them in the chat here, and I will address them when I get back in a minute. I'll put myself in a few minutes. I'm going to put myself on mute. Okay, I'm back. I'm conscious we have about another 5 minutes, but yeah, if anyone has any questions for me or anything like that, I'm back here for the next few minutes before we start up. I'll actually, while I'm talking, I will run. Just check that, make sure that query about the number of items was correct, but I'm pretty sure it is. I believe there's about I think there's about 5,000 products in there. Is it product? Is it stock codes? Lookup. 6,000. Oh wow. Hold on. No, there's correct. Ah, yeah. Okay, that's what I thought. So there's about 4,778. So there's just under 5,000 products. And then if I just have a quick look here. So if we yeah, so there's about 4,000 products that don't get a cluster under that system. So yeah, just turn on my video. But then again, I mean, maybe that's useful. I mean, it's tough to say. I mean, in some ways, maybe those 4,000, because they're not being picked up by the association rules data set, maybe the business just, it's like the long tail effect, and those ones you don't necessarily need to pay attention to, or maybe you do. It really depends on the use case. I'm not, maybe that you're looking to reduce your stock offerings, and because you know that you've got this big long tail of products that are difficult to manage in terms of your warehousing, whatever, because you're dealing with physical things. So maybe, warehouse spaces at a premium, or you're trying to figure out what can you cull from your stock. So that's maybe, maybe you just want to focus at the top 1,000 items that seem to be relevant to one another. I'll give people another couple of minutes to get back. Yes, I have, Patrick. That's what we're going to do in the next part. We're going to.
You then.
Oh, hi, Paddy.
How are you now? Yeah, I was going to say, because when you had that graph there, looking the interactive one, obviously was just the product ID. As you get product names, it's that bit more intuitive to explore.
Yeah. Well, then, so go on, sorry.
And when when I was asking there about do you show that to the business, because you go through so many stages of analysis, it goes here's something that's decent to actually, okay, I'll let them play with it or not. And it's a difficult one to call.
Yeah, because you could be making a rod for your own back. I mean, it's very much a judgment call. When in doubt, I would err on the side of giving them something rather than giving them nothing, because there is always the cycle. Don't underestimate the power of the fact that you've actually delivered something, even if it's not particularly valuable, especially if you can turn around something relatively quick. like in a couple of days or maybe a week or whatever, then that can be very, very powerful.
Yeah.
But of course, the flip side is that you end up getting asked a whole load of questions that just make things worse. I know.
That's exactly, I was going to say.
I did once end up in a room working for an insurance company, let's just say in the UK, that relatively senior actuarial people who we thought understood statistical models, and it became very apparent. So we were presenting like some results of models. It became very apparent very quickly that they didn't understand modeling at all, because we ended up having to explain how models work. And I've never really made that mistake ever again. Just show the results of models and maybe some high level parameters, but you don't want to be discussing applied statistics in a business meeting. And so it's a trade-off. But I think if I had to choose, I would generally find something to give them.
I would say assess the level of the individual before you give it to them. So especially in terms of technicality.
Find something very simple. Where it's like, even if it's just like, you mock up something really quickly in Power BI, and it gives them some like high level, even something really simple, like if you've got like some kind of way of slicing and dicing the data and giving them like an interactive dashboard where they can click on different things and see like total sales change, or the profit or whatever it is. Don't underestimate how powerful that can be.
Yeah.
And that's something you can probably get quite quickly.
Yeah, because I was going to say there, in terms of if you have someone who's higher up who understands acyclic graphs, and it's just like, here you go, here's a graph network of all these products, and they're like, have fun with that, and he goes, oh yeah, excellent, rather than giving that to someone and then teach them how to use it. It's like, okay, no, you're just wasting your time. So as I say, that's how you assess who you're kind of giving it to even before that.
Yeah, definitely. Okay, so it's 5 past, so we'll start back. So let me just, have I turned on my camera? I think I did. Okay. What am I trying to say here? It's probably worth taking a quick step back before we start back. Let's just take a quick step back, and because I just realized I kind of dived in and I didn't really talk about what I decided to do. So we did a bunch of stuff, and because we didn't really have any kind of like remit for this project, we can essentially go where the data leads us. So in terms of what we've done, what I've decided to do is essentially do a kind of a descriptive analysis, let's say, of some customer segmentation. So we can do some customer segmentation, and we can do some product segmentation, and then we can kind of do a two-way join between those. So what we would like to be able to do is not only identify different types of customer in terms of, and that's very simple. It's like essentially good customers and bad customers. And also then using the product splits that we have, what type of products do these various customers buy? And then, that kind of forms the basis of what we can deliver. Now, it's somewhat arbitrary, and it's also probably not as complete as I would like it to be, because of the limitations that we are kind of faced with. Like, we don't have a proper stakeholder, and the data we have is somewhat incomplete and flawed. So we're not really able to give as rich an answer as we would probably normally be able to give. But basically what we want to be able to do is, like I said, segment these customers, segment the products. Ideally, in the groups of products that we've segmented, get some insight into what the different clusters mean. That's always the hardest part, typically, of cluster analysis, is actually then going into each cluster and figuring out, what do the elements in this cluster have in common with the elements in this cluster, or in, all these elements in this cluster, and why are they different to these and all that. Now, we're relatively limited in how we can do that here, because typically what you get with clustering is you have a whole load of data points, and they'll come with a whole load of information. And then you have a clustering routine that, takes all that information and creates clusters. In this case, we've done our clustering very differently. What we've done is we've built a big graph of all the transactions and all the products in those transactions. And then we've done a clustering, what's called community detection, on those on that graph. So essentially what we're looking for is, if there's a bunch of products that are kind of clustered together, and there's then a small number of connections to this other cluster of products, and then these are two separate clusters, and well, what can we say about these products, and what can we say about these products? There's not a whole lot we can actually say about the products, really, because we just don't have a lot of information on it. Basically, all we really have is that description field. But we do have a couple of NLP tools that we can use. So I did some very basic stuff on that, but we'll talk about that in a second. So let us just move on to, whoops, let me get on here. This is the problem with the iGraph stuff. So like I said, we want to look at the transaction-based clusters. So instead, we basically split off the disjoint components. We've created a graph of the data, and we could do this group components. What that does is essentially it looks at all the separate disjoint parts of the graph. So if there's essentially a bunch of if the graph we've created have completely disjoint, so essentially there's disjoint subgraphs within the overall graph, we're pulling them aside. We're going to look at them, and there is a couple of different. As you can see, it's a graph with 6 components, so we can do that. And now we want to check the sizes of the disjoint components of this graph. So we can see here there's like one component with over like 4,600 products, and then a bunch of clusters that have just one product in it. So basically the rest of it is just single standalone products we're not really going to look at. They're basically off by themselves. We'll ignore all of them, and we'll basically treat this big graph as the main one. So when you plug that in, we can now do a number of, again, the clustering routines. Now, I didn't really talk about this because I was conscious of the time, but essentially what happens with a community, it's called community detection in graphs, but it's the similar idea of clustering, in that what you're trying to do is you're looking at a graph as a whole, and you're trying to find areas that have dense connections to each other, and then other areas of the graph that have a smaller number of connections to them, and then you essentially call those different communities within the network, and those become your clusters. Okay, and there's a bunch of different ways of doing that. That's what all these different things are. So there's fast, greedy, and lead and eigen, and some of them use kind of very simple heuristics in terms of how many jumps it takes to get from one to another, and it kind of has a bunch of different ways of doing that. Others basically turn the graph into a big matrix, which you can do through adjacency. It creates a big, and then it does some like fancy linear algebra on the graph, on that matrix, the matrix that represents the graph, and then you based on eigenvalue decomposition and all those kind of fancy mathematics, you can create your communities from that. So I did a bunch of things, and eventually I boiled down to this group Louvain, because you can see here, going off the previous one again, these are the different cluster sizes. So we end up with what, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different clusters. One of them has 1 in it. The next one has 66 items, 122 on it. So you can see we're also getting a pretty nice spread of sizes, which is more kind of what I had in mind. Now, I can't really give a strong statistical justification for this. Whereas you can see leading eigen, this method produces 2 clusters. One has 876 in it, and this is over 3,500. And then whereas this has a whole load of different sizes info map. Now, but the problem is there's very much, now actually fast greedy might not be too bad, but this one here you can see there's a whole bunch of small clusters and then one big massive one. Now you could start going recursively down. There's loads of different things you can do here. What I wanted to do was get something almost to prove the concept. So I have all these different, I have 10 different clusters here, and I can assign each of these products to one of these clusters, and those become my product split. Okay. So, I was looking for an even split. Now, I don't have a good answer for why that's the best way of clustering. And again, this boils down to A, because we don't really know what we're doing here and we don't have a better set of data. But also just my gut feeling was that I wanted it to be, I didn't want to have a completely lopsided clustering where you have, a few thousand products in one cluster and then, double digits in the rest. That just didn't seem that useful to me. Whereas this seems to give, obviously it's going to be uneven because you would expect that, but this seems to have a nice set of clusters in it. I'm not quite sure how Louvain works. I did look this up a while back, but I've forgotten what it does. I won't even try to remember it. But it gives us a decent split. So those are the ones we're going to do. And then once we have it, then we cluster the large component, and it gives us, we create this split. And essentially, once we combine it all, we have a stock code, a product group that it's assigned to, and then the thing it's in. So we end up essentially with a nice clustering of pretty much all the products in the data set, right? Now we will analyze this a little bit later, but for now we now effectively have a rough clustering of all the products that we get, right? So now what we can then do is we want to look at the cohorting of our customers using some other models that we looked at earlier in the project, and then essentially do a two-way look. So how can we combine the different types of customers and the products they buy? Okay. Before I move on to that, now I'm conscious that this was kind of a bit long-winded, I managed to be both long-winded and going very quickly through the topic as well. So if anyone has any questions, please by all means pop it into the chat. I am keeping an eye on it here, but failing that, I'm going to move on. So we now have a split of and we have as you can see there, we have a reasonably decent split of stuff. There's a couple of hundred at least. Well, okay, there's 1 in 66, but it's certainly the least unequal. It's the most egalitarian split. Now, there is an argument to be made that maybe it shouldn't be that egalitarian, and maybe there is a very lopsided clustering of that. But my gut feeling was I wanted a bit more resolution in my clusters. And again, sometimes you just get a gut for these things and you kind of go with that. Now, it could be proved wrong. And if we do a deeper dive into all of this, which I probably will do at some point, I might prove to be totally wrong in this. And really one of these other ones here, like, maybe this one here is a much better look at it because there's only 4 clusters, but they all have a whole load of products in them. And maybe that's a better way to look at it and a lot less arbitrary, because there is a certain amount of arbitrariness in your clustering as well. Like sometimes, sometimes you're better off just having a smaller number of very broad brush clusters rather than getting the refinement from it, because, you might actually essentially be clustering on noise at that point and not really capturing anything significant. But okay, so now we're going to move on to our RFM segment. So for those of you who did this, we did this, I think, 2 workshops ago. So the RFM model is really, really simple. And in some ways, I think it's too simple, but it works. And I mean, you could write your own code if you really wanted to do a better analysis of this. But essentially what it does is it's RFM, which means recency, frequency, and monetary, which are the kind of the 3 aspects that you care about. So the recency is how recent since the customer last made a transaction. And that those are typically better because they found that the customers who have transacted with you most recently are more likely to repeat their business. There's a strong connection between the recency of a customer and the likelihood of a customer transacting again. There's also the frequency model, as in how not the frequency model, but the frequency measure, which is how often have they transacted. So in other words, how many transactions have they made? And the monetary, which is how much have they spent when they spend, right? And all the RFM model does is it basically takes all the customers, it calculates a metric for recency, a metric for frequency, and a metric for monetary. In this particular case, the recency, I think, is the number of days or weeks since the last transaction. The frequency is the total number of transactions made by a customer, and the monetary is the total amount spent by the customer. Now, immediately, one of the problems I have with this model, sorry, not with the approach, but with the way they're calculating these numbers, is there's a certain amount of interdependency there. So if you have transacted a lot, your monetary number is going to be biased upwards because you're transacting more so therefore you're spending more. So I think I would prefer it if the monetary amount was the average spent, because that would kind of break up that dependency between frequency and monetary a bit. But the way the package works is it just kind of does all this stuff. And I just wanted to go with that. I mean, it would be very, very easy to roll your own though. And if this had legs, and if this was kind of something that, you know, we were repeating the analysis, I would probably repeat some of this, but I would probably change the monetary to calculate an average amount rather than a total, because that's one thing that kind of bothers me a bit. And then what you do is, once you've done all that, you basically split them into quintiles. So you basically stack them in order, and the top 20% gets labeled, I think it's 5, and the lowest one gets a 1. And you do that for your recency, certain RFM. So essentially each customer gets a code, an RFM code, which is basically a 3-digit code that is, it's quintile for recency, it's quintile for frequency, and it's quintile for monetary. And then all we do is, in terms of splitting them up, we kind of decide these somewhat arbitrarily. Now, these were set by the package themselves. So you basically go down the list and you say, well, when allocating them to a segment, you basically say, well, is there recency 4 or 5? Is there frequency 4 or 5? And is there monetary 4 or 5? And if they are, they're a champion. Otherwise, you check the next one and you go down the list, because you see there's overlap. Like a loyal customer, if someone is a champion, they automatically qualify for a loyal customer as well, right? So you can kind of see that there. So instead, what you do is you basically go down the list, and they get allocated to the first one they match, basically. So you can see here, like a new customer has a very high recency. They very recently transacted, but they have a very small number of transactions, and they have spent a relatively small amount of money. So, you know, how do we? So we just do that. So it's very, very simple. I mean, there's a package that does this, but it would be essentially a homework exercise to code this up yourself if you wanted to. And that has the benefit of, if you wanted to tweak this in certain ways, it would be very easy to do that. And essentially, from what I can tell, I mean, these were provided by the package, but they kind of make sense in the long run. Like, you know, can't lose them. So, you know, someone who hasn't transacted in ages, but when they did transact, they transacted a lot and they spent a lot of money. So, you know, but they haven't their recency is really bad. It's been ages since they transacted. So, you know, those are kind of the different customers that we get. And I've just shown them this 10, and you can have as many as you want. I mean, I wouldn't have too many, but, you know, they kind of provide you the different things that you might want in terms of how they work. So and then we assign them. So you can see here, like, yeah, we have the customer ID, the date, and then we have an RFM score. And then we just look at the different data. So we did all this before. Now, the big benefit of this is, and this goes back to the early point I was making with the conversation earlier, is this is really, really easy to understand. So anyone can understand this, realistically speaking. And from anecdotal information that I've heard, marketing people in particular loved this analysis, because marketing people typically aren't technical, and it's something they can understand, and it's also something they can use. Now, as a data guy and a stats guy and all that, it's very easy to mock marketing people, but anyone who's ever had a business that doesn't have good marketing and can't get any sales, you know, it's a huge important part of the business. And, you know, giving someone simple that's useful, that they can understand, that means it'll get used. So therefore you're creating value by doing it. So don't, I actually overlooked this completely. I had the package, there's a package called RFM that does all of this. I managed to overlook it for the first couple of workshops. And finally, when I was actually working on the buy till you die models, I thought RFM also had a bit of BTYD in it. And when I discovered what it was, I immediately realized that buy till you die was going out the window, because it's just far too complicated. And while it does have an awful lot more statistical sophistication and probably has more predictive power, it's also way more complicated to explain. Whereas this is nice and simple. And to be fair to it, it actually produces some pretty decent results when we look at it, especially champions. So when you identify your champions, so the ones who have the highest scores in the 3 metrics, we're going to do a little bit of validation shortly. And when we compare it, basically, so the idea is we go up to our training date, which we arbitrarily set to be the 31st of March, 2011. So we have about 9 months of validation data to look at. And what I did was I used all the data up to that point, essentially to allocate all the customers to these values. And then we looked at how did those same customers perform after the cutoff point, and how do they work. So that's one of the things we're actually going to look at. So when we look at the visualized data, let's just scroll down. But these are all kind of inbuilt things. So we have our customer segments. So we can see here, we've actually, we've over 1,000 customers that count as being champions. We've, about 500 that are lost. So there's the different, decent number of loyal customers and a decent amount of potential loyalists. So, it's a very interesting segmentation where there's essentially about 3,000 customers that are still effectively providing value to the business. Not that very many of them have kind of dropped off. And then, we did some box plots based on their metrics. So based on the different things. Now you would expect this, this is going to reflect how we've defined them, because recency, total spend, and transactions is how we're doing the split. So we would expect the different groups to be kind of distinct from one another. But the next thing we can actually do is do a bit of validation. So what we take is, like I said, we take all the customers and their allocation before we've done the validation point. We keep that assignment of segment to after the cutoff point, and then we calculate those values again. So when we look at the validation, it's not as good. And we can see here that in terms of the proportion of the data set, there's actually there's a lot more champions in the valid. Actually, proportionally speaking, though, there's still quite a lot of champions in there, loyal customers. So that, like, apart from potential loyalists, they've kind of dropped off. So this is just, we're comparing here the proportion of customers in the validation set, as in before the cutoff, to the proportion of each allocation after the data set. And we will remove all the newly arrived customers. So customers that only started trading after the cutoff point, we're excluding them from the analysis. So we're just looking at how the proportions change. And we do actually see that there's a lot more champions surviving, but I guess we would expect that, right? Because as customers drop off, we would expect the champions to kind of stay, because and also don't forget that some customers won't have transacted at all. So there's a certain amount of skew in that. And that's something we could also look at. I may have done that here. I certainly did it at one point, like how many cut off. But now what we're looking at, so here, what we're doing is we are creating the different cohorts based on the validation data. So we've created box plots. So again, we've taken the data after the cutoff point. We've calculated our recency value, our total spend, and our transaction count. So the three metrics we're using for the RFM. And then we're saying, how did those customers that were around before the cutoff point, how do they exist? How do they compare after the cutoff point? So we wouldn't expect there to be as much of a difference, but we can actually see here. Now, this is all on the log scale because I needed to use the log scale. So you can see, like, basically our champions do better on every metric. So they transact more recently. They have more transactions. You can see they're clearly above the rest. So champions definitely stand out. So the identification of champions is definitely a valid one. Now, I have heard that in retail in general, that basically your customers who spend more and transact more most recently are the valuable ones that you try and keep, because you just keep them buying stuff because it makes them more likely to come back. Now, there was differences in the other ones, though. If you look at loyal customers, now again, it's a little bit skewed here because of the thing, but you can see here the orange is slightly above. Now, it's not massively above, but on a log scale, you can definitely see that there's a difference with loyal customers and these others as well. So, and that's a total spend. Now, again, one of the issues with it, see you, Patrick. One of the issues we do have with this is I don't like this total spend metric because it's kind of tied in with the transaction count. So if there's, if you've got a high number of transactions, there's going to be a bias up on the total spend as well, which I don't really like, but we can live with it. We can also, and box plots can sometimes be harder to see. So we did some violin plots, which is like there's also kind of a hard limit on the recency because we have it. You can see basically there's a line here, and that's because there's only a certain amount of time that we've been able to observe customers, and that's kind of what we're seeing there. So like no customer has gone. So if a customer transacted right at the start of us capturing the data set, and we've got whatever data we have today, that's the maximum amount of recency we kind of observed from that customer or from any customer. So you can see that's kind of, we're seeing these kind of weird artifacts. When you see artifacts like this in the data set, it's always worth asking yourself why it's there. Now, sometimes it's a very simple answer, like the one we just said. You know, essentially it's censored values that we can record, but it's, you know, it's okay for that. So we now have our customers, and we have a customer segmentation. We mainly care about our champions, but also potential loyalists are also kind of useful. You can see they're kind of in the same in terms of the total spend, and they're kind of similar in terms of the transaction count, but they are a bit ahead of some of the other clusters on this one here. Now it's so this is the downside. I think when you plot it without the, well, you know what? Let's do it. Let me just plot this and get rid of the, what I'm going to do here is get rid of the, oh, hold on, here's what I should do. It's in inspect segment validation. So let me bring this up. Go models. What I'm trying to do here is essentially recreate the plot without this the log scaling. The log scaling does skew it somewhat. Let's put that up there, and let's go up here. There we go. So if I go segmentation plots, it's going to go through that, and it produces the plot. It should. No. Okay, this is why we don't code live, folks. This should work. Hold on. Just try that one more time. There we go. So let's get rid of the log 10. Let's get rid of the log scale on the y-axis and do this again and see what happens. And I think what happens is you get this just mad skew. It gets rid of it and just it's harder to, oh, no, it's not too bad actually. Oh yeah, but over here we do, because we have these crazy amounts. You have this crazy mad spends, which kind of skew everything. So we kind of have to get rid of them. So yeah, so that's generally why putting it in, but it does make it a bit more awkward to get that analysis. So basically we have found though that champions are definitely good, and both potential loyalists and whatever the other one was called, loyal customers, these two in particular, they're kind of the three that we kind of are worth doing a bit of analysis on. All right. Okay, so we have a segmentation. So it's half I can fit this in. So we have basically every customer has now been allocated to a cohort, or a segment, I should say. So we now have a segment for each customer, and we also have products, and each product is assigned to a cluster, a transaction cluster, right? So we now have, but we also have all the transactions that basically each transaction has a customer ID that we can assign to a, so let's go back to our customer data, right? And I'm going to skip all this. So basically what I did here is I took all the products and I took all those descriptions that we talked about half an hour ago, and I collapsed all the data, and I just created a word cloud to see if anything stood out. And it doesn't really, to be honest. To me, that's a bit of a mess, and that was a bit of a dead duck. Now, I kind of, because some of them were kind of very similar, what I took was I took each word and then deduped each word. So in some cases, it would be like, you know, Christmas light green, and then in the other cases, it would be green Christmas light. So what I did was I took each word, and basically I took, if there was different descriptions, I joined them all up, and then I took each individual word and I made each word unique, and then that became the input to the word cloud. So word clouds are really handy though. They get a bit of bad rep because they're very simple. But again, going back to the logic of doing something simple that people can understand, this hasn't been particularly useful. It can be amazing how useful a word cloud can be though. And again, going back to the point of talking to people and giving them something they can understand and not making them feel stupid. You know, if these things stand out and they can make it look cool. I mean, this is also a thing with a bit of work, you could probably make this look kind of cool. And again, even if it's not particularly useful, the fact that people can play with it and generate their own word clouds, you have a little tool that lets them do that, you know, that can go an awful long way to actually showing people that you're actually doing something of value, even if you don't think it's particularly valuable. Okay, right. So the final thing we're going to do here is, like I said, we've got these customer and product allocations, but essentially what we have is we have all our transactions, and each transaction has a stock code and a customer ID. But each stock code has a transaction cluster, sorry, a product cluster, and each customer has a customer segment. So essentially we can turn each entry in our transaction database into a customer segment and a product cluster. And now we have basically a big long table of those two categoricals. And what we'd like to do is do what's called some correspondence analysis. Now I'm calling it a co-occurrence analysis, but essentially it's kind of like the idea of correlation, but for categorical variables. Okay, now this is something I kind of had to learn for this. I knew it existed, but I didn't really know how it works. Now, I haven't done a very detailed analysis here. Again, this is another rabbit hole I could have very easily gone down. I didn't want to do that simply because I don't think it really needs it, but there's definitely a lot more analysis that could be done here, because you can actually have multiple categorical variables and do what's called multiple correspondence analysis, which is essentially like for multiple, rather than two categorical like pairs of variables, you could have 3, 4, 5. And there's some very natural categoricals in here. We could start adding like the cohort of the customer, or we could start adding the transaction. We could start looking at the month or the day or various other things that we could start looking at and seeing how they all co-occur. And again, I think that could be very valuable from the point of view of saying, okay, well, these particular customers buy this particular type of product on this particular day or this time of the, this month of the year. Now, obviously, there'll be obvious co-occurrences there when you've got seasonal stuff, but it might also dig out, unintuitive things that you might not really get without doing some data analysis on it. But we're not going kind of down the rabbit hole. I'm just doing a really simple thing where I'm checking what's the codependency between the customer segment and the product group. Nice and simple. So how do we actually do that? So I've kind of done a little bit of kind of theoretical. So essentially the way we look at it is, the way to kind of check if there's essentially an interaction between the two, because if you've ever done regression modeling, kind of we're dealing with interactions here. So one way to look at it is, well, what's the general proportion? If we look at all the customers, what proportion of customers are in segment 1 and segment 2? So like your champions and your at risk, and there will be a proportion of them, right? And they will all, so each customer segment will have a certain proportion, right? And then you will also do the exact same thing for the transactions. So what proportion of products is in transaction 10 and 9 and all them, right? So we essentially end up with two marginal distributions. And if there was no connection between any of them, so in other words, if there's no connection between the types of products champions tend to buy, well, then we would expect that the relative, like if we then look at the whole data set and say, okay, well, what proportion of combination of champion and transaction product is there? Well, then that should be just equal to the product of the two proportions. Okay, so to put it more concretely, let's say, for example, our champions are 10% of our data set, and let's say our product cluster 5 is 10% of our products. So then we would expect a champion would buy a product in cluster 5 with a frequency of 0.01, because it's 0.1 times 0.1. right? And any deviation from 0.01 is essentially due to the interaction of the two. Now, obviously, due to random noise and stuff, you don't expect it to be exactly 0.1. But let's say, for example, instead of 0.01, we observe 0.08, right? That's 8 times bigger than we expected it to be. So there's probably an interaction between the two, okay? So what we're saying is that champions are more likely to buy products if they're in this cluster, product cluster, okay? So that's the basis of like the analysis that's done here. You build up what are called like contingency tables, which are just counts of the co-occurrence of everything, and then how those deviate from what you would expect theoretically based on the marginal proportions. So we can see here, for example, I've just done some numbers here, and I've just taken the difference in the expected proportion. So you can see here that champions, for example, have a much bigger propensity to buy from cluster 7, and they're less likely to buy from cluster 4, right? Because the theoretical difference is much lower. Now, these are based on absolute differences. So it's a proportion minus a proportion. So there's no scaling here. So the other thing I did here was look at the percentage change. So, and that gives you a very different view, where basically you can see here, like the about to sleep product, these customers here in the about to sleep categorization were way more likely to buy transaction 5 than you would expect based on, you know, the independent proportions alone. And that changes the thing. You can see champions actually have a pretty broad brush. A lot they're more likely to buy some and slightly less likely to buy others. But, you know, overall, you know, you can see here that these kind of color, and I've put the color here in the tiling, and that kind of gives you an idea of there is basically an interaction between product group and customer segment. Okay. Now, again, I'm not really, I kind of included this in here because this was kind of the type of thing I was doing when I was like, there is some books that explain all of this, but I found them a little bit like mathematical, and I was just trying to get some intuition for all this, and I didn't want to be drowned in, you know, sigma signs and stuff like that. So I thought this is kind of, I put these in there. By all means, have a look at the code if you're interested in this stuff. But this is the basic idea. So essentially what you do is you create these contingency tables, and then you create these theoretical contingency tables, and you essentially do an analysis of the two, and you combine them. And we have some balloon plots. I mean, I won't get into the details. But essentially what we're doing here in the correspondence analysis is we're doing a similar idea. But effectively, without going into too much detail, what you can do is you look at these products, you look at these relative proportions and compare them to their theoretical. And then depending on whether you want to look, you can kind of look at them in two different directions. You can look at it from a product perspective and do some analysis, and you can look at it from a customer segment and do some analysis. And then essentially some very clever people have figured a way to combine the two and produce what's called this biplot, right? So a biplot is kind of similar to, you're essentially doing something similar to I'm trying to think of the word for it, covariance matrices. So it's a PCA. Sorry, thank you, Patty. PCA. You're essentially doing PCA on these frequency tables, okay? And it's a similar idea. So you're creating these cohorts, and basically what it means is that if you can see here the cohorts, the customer cohorts are plotted in blue with a circle, and the product transactions are plotted with a red triangle. And effectively what it means is that there's essentially a co-occurrence relationship between them if they're close together on the plot. So essentially you can see here that champions have this tendency to buy from transaction 10 and transaction 9 because they're kind of close to one another. Also, potential loyalists and others are kind of related to TNX 5 and TNX 4. Now, this is a very unsupervised kind of exploratory high level thing. You're not looking at this for any kind of like statistical validity or any of those kind of things. This is much more kind of an indicative thing of like, oh, we should probably look at, you know, champions and these kind of things. And biplots get used a lot for this. Now, I realize what I'm talking here is really hand wavy and not nearly as rigid as you should be. I basically don't have time. We could probably actually do a workshop series on this, and I might at some point, maybe next year, depending on how things go. There's three things I want to talk about. One of them, which I'll definitely do, is customer lifetime value with Bayesian analysis, but I'd also like to do something on NLP, and I'd like to do something on correspondence analysis, because I think they're out there and they're pretty well established in the applied statistics world, but they're something that doesn't really get taught from what I can tell. And there's a couple of decent books on them, and this is something I would definitely like to understand better. So you're looking at someone here who does not have all the answers to this, but what I can say is from the point of view of a biplot, you know, it's handy for kind of giving you an idea of what are the interactions between the customer segment and the product grouping. And you can see here that champions have this kind of set there. And basically, as a result of that, those products in 2.9, we ignore TNX10 because it's very small. But let's just remember the word cloud. So we can kind of see here, they have a card. So I've gone back to my word cloud for this TNX09 and done the word cloud. So wrapping paper and cards. So it seems to be kind of present based and gifts. So gift type stuff tends to be our loyal customers. Potential loyalists are connected to transaction 5. So this is a word cloud here. Yeah, this seems more like decorative stuff. So yeah, so so that's where we've got to. So it's still a bit loosey-goosey, unfortunately, and we're getting ready to wrap up now because I notice it's about 8:45. It's not perfect by any means, because what I would like to have is something a bit more solid to give people. But essentially what we can do now at the end is we can essentially give the stakeholder a very simple, easy to digest and understand customer segmentation, and give up a basic idea of, you know, give them a basic idea of the different types of customers, how we did it, and what they, you know, what you can do with it. But we can also then say, and then there is a tendency for the customers in the cohorts we care about to buy this subset of your products, because they all tend to co-occur in the trades, in the transactions, and these customers are associated more with these types of customers. So again, it's kind of like using the association rules idea. So like, if a customer is in this particular cohort, they're more likely to buy this type of product, because, you know, customers buy this type of product, but customers in this cohort buy it more than any other type of customer, that sort of thing. So basically, we have kind of a story to tell. It's still a bit muddled though. It's not ideal. And that's kind of all the modeling we're going to do for this. It's not perfect, but we're also kind of limited by the data that we have in terms of the thing. Now, having said that, I am totally open to being wrong about this. And if anyone here today has an idea about things I've missed that could be useful for this kind of stuff, I am all ears, and I will more than happily cover it in the next workshop, which will at this point be in December. So in December, what we're kind of going to leave the modeling here, but when we come back in the final workshop, we're basically going to focus on what we deliver to the end user. Now, what I'm thinking along the lines of, we'll create another workshop, we'll create another workbook. I mean, there won't be that much detail in it. We'll just have a series of visualizations that they can look at. We'll probably have some relatively simple slicey dicey type stuff. Some of it will lift straight out of our data exploration, because some of that is probably of use to them, like some of the time series trends. Like, I know it sounds really simple, but it's entirely possible the people that you're talking to have never looked at the data in a way that you think is obvious, that you may have done on the very first day. That has been my experience in the past, that you might be just looking at it in a way that they're not used to. So I would definitely present all of that. But the other thing we also discovered as a result of our wanderings is there's a couple of ready-built tools using our Shiny that we can kind of use immediately. And we can just essentially spin up a Shiny machine and like give them the URL and point it at it and let it. So we're going to talk a bit about that. And then what we might also do is maybe build a really simple Shiny app, although I'm reluctant to go down that road because that would involve showing you how to build Shiny. And maybe it's simpler to just take a dashboard and build something in Power BI or something like that. But basically in the next workshop, we're going to tie a bow on this whole project, and we're going to talk about how we take the results that we've had now, which is basically our customer segmentation and our product clustering, and how they interact with one another, and some basic exploration stuff. And we're going to present, basically take all those bits together, and that's going to be like essentially what we hand over as the final results of the project. Okay, so I'm noticing it's about 10 to 9 now. That's a good place to stop. What I'll do is I'm going to stop recording now, but I'm going to stay on for a little while longer. If anyone has any questions or ideas or something they want to ask me about, by all means do it. But before we do that, rather than record that, I'm just going to stop it now. This will go up on YouTube onto the channel as part of the work group, as part of the playlist, I should say. And yeah, and we'll stop recording now. Oops, that was stop the share. Sorry, wrong thing. I want to keep the share. Wrong thing I hit. Share. Make sure I can still share this. Should stop the recording.